Today we are going to do this problem from ICSE 2019 Mathematics paper, question number 2, part C. And let's read the question. In an arithmetic progression, fourth term is 8, the sixth term is 14. Then you have to find the common difference or the difference between two consecutive terms. The first term which we started with, and the sum of 20 terms, the first 20 terms. Okay, so pause this video and try this question on your own, and when you're ready, unpause it to review the answer. Okay, so let's go ahead. So how do you get new terms in an AP? We have the first term, A1, the subscript tells you which term it is, and when you go to A2, you add some common difference D to get to A2. Similarly, you can add the same common difference to get to A3 and so on. That's how you get new terms. So if you are at the fourth term, and that is 8, you add some difference D, you get to A5, and you add that same difference D again, so twice D, you get to A6, which I know is 14, which means that 8 plus 2D is equal to 14. Very nice. We can now figure out the common difference by solving this linear equation, which means that D is equal to 14 minus 8, that's 6, divided by 2, that's 3. So the common difference is 3. Well, so we found that, that's 3. What's the first term? Well, now we can reverse the process. We know that the fourth term is 8, and we have gone till there by adding D 3 times. So the first term plus thrice of D is equal to 8. That's what we know. We know what is D, that is 3. So now we can figure out A1 by simply solving this simple linear equation in one variable. So A1 is 8 minus 9, that's negative 1. Okay, very nice. We found the first term, that's negative 1. And the sum of first 20 terms. Now you have a very nice formula for it, but now we will be deriving that formula. Basically, I will be doing this for this case, but you can later on generalize it. Okay, so let's calculate it. So let's say the sum of first 20 terms, I will represent it by S sub 20. That subscript tells me that it is the sum of the first 20 terms. That is equal to the first term plus the second term, that will be 3 more, plus the third term, and so on, till what would be the last term? Well, the 20th term. In order to get the fourth term, we added it thrice, added the common difference thrice, because we don't need to add the common difference when we are viewing the first term. So it should be the first term, negative 1, plus 20 minus 1 times the common difference, so 19 times 3. What is 19 times 3 equal to? 19 times 3 is 57. That's 20 minus 1, that's 60 minus, yeah. 57 minus 1, that's 56. Okay, what do we do next? I don't want to add them all up, like negative 1 plus 2, that's 1 plus 5, 6. That would take me the whole day. I won't have the whole day. Okay, now here's a trick. This trick is known as the Gauss trick, because that's the name of the person who discovered it. Okay, so what I'm gonna do is take this S20, our variable which we want to find, and I'm gonna flip it. Okay, so this 56 is gonna stick around here. Then the next term would be 3 less than 56, that's 53. The next term is gonna be less than 53, 3 less than 53, that's 50, and so on till the last term. We have just flipped it, so the first term becomes the last term. It's negative 1. Now, magic. We are going to add these 2 times whatever I want to find, S20, 56 plus negative 1. What's that? That's 55. That's the same thing as 56 minus 1. So 53 plus 2 is 55. 50 plus 5 is 55. Dot 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 dot. The last term is 55. Did you see that? Okay. Every term is the same now. Now how many terms were there in this one? How many terms were there? Well, we already know. It's the sum of first 20 terms. So there were 20 terms. 55 added to itself 20 times. That's the same thing as 55 times 20. That's how we define multiplication. Which means that 2 times S20 is 55 times 20. Because that's the number of terms. Here. There are 20 terms. There still are 20 terms because it did not cancel anything. Which means that S sub 20 is 55 into 20 over 2. Dirty cancellation. That's 550. We found the answer. Really simple. Very nice. And what I want you to do is to generalize this formula for all the arithmetic sequences, any general arithmetic sequence. And this formula is beautiful, no matter what you say. Okay, so thank you for watching this video.